In this video, we're going to go over the following question. Feel free to pause the video here so you can read the full question. But to summarize what the question is, basically this person has created a mesh and they have found a crack or a separation in the mesh like you see here in the animation. So the question is, how do you fix this issue? So go to the meshing tab. Here in the group of buttons for FEM actions, hover over this button with a bunch of dots. This is the equivalence button. Click on this button. You then get this new menu here on the right. Click apply. This is going to equivalence duplicate nodes. So here, if you look at these pink markers, these are where the duplicate nodes were located, and I'll make some more comments about this in a moment. What I'm going to do now is I'm going to repeat the analysis and look at the new animations, and you'll see that the problem has been resolved. So let's go ahead and run Patran right now. Let's go ahead and import the results, and let's go ahead and look at maybe the first mode shape. So let's go ahead and select this and this. We'll turn on the animate option. Then here in the far right hand tab, which would be this button, we're going to type in a number of frames of 50. Then we'll go ahead and click apply. Now when you do this, the animation is kind of fast. So here there's a horizontal bar that controls the speed of the animation. So I like to move this a little to the left just so it slows down a little. If you want, you can move it to the right and it goes faster. So you can see that the crack that we had before is no longer here. And that's because we've equivalenced the mesh. Now, at this point, I can go ahead and talk about why this happens so it's more clear as to why this is happening. So let me go ahead and reset the view here. And let me delete the mesh. So let's go ahead and delete the mesh if I can. So I believe if I select this, it deletes the mesh. So here we have our geometry. If you go to the home tab and click on this button, smooth shaded, this is going to show you the actual geometry. We're going to mesh the geometry, but notice that there is a so-called free edge that you see here. It's very hard to notice this, so let me do this. Let me see if I can do this in Patran, or not in Patran, but in MSC Apex. So what I want to do is create a circle here. Let me see if I can do this quickly. Let me zoom out. What I want to do is create a nearly full circle with a small gap in it. So let me zoom out a little. Let me start here maybe. And then we'll maybe sweep it like this. And I don't know if I can actually sweep it that far. We'll try. Okay, yeah, this looks pretty good. So we're going to get very, very close. Okay, there. And then we'll go ahead and exit this. And we'll go ahead and make a copy of this real quick. Notice that there's a gap here in the circle, and I'll explain why this gap was introduced purposely. So let's go ahead and maybe clone this. Let me rotate this a little. What I'm doing in MSC Apex, I'm essentially going to rebuild the cylinder with this gap in the geometry. So let's go ahead and do that right now. And then we're going to exit the transform tool that was used to copy that circle. And then we're going to use the filler tool here in the geometry edit tools. And then we'll go ahead and click on the filler option. And then here we'll click the first edge and then the second edge. And here it doesn't want to let me select the edges. So you can disable the auto execute option. So that would be this lightning bolt. So select the first edge. And then select the second edge. And then click the middle mouse button, which would be the scroll wheel. And now you see this. We have a crack in the geometry. Now, when you're in Patran and you build this geometry, the gap is so small that it's not noticeable. But a clue that there's a gap here is the following. Let's go ahead and create a quick mesh on this. So maybe we'll use a mesh size of maybe 0.1. Yeah, 0.1 looks pretty good. Now, what we're going to do is there's a lot being displayed right now. We have the geometry, and then we have the mesh that's on top of it. Sometimes it gets a little confusing. You can see that the mesh lines aren't displayed properly from this orientation, and then when you flip it, the mesh is displayed properly. This is because the geometry and the mesh is overlapping. So we turn off the geometry. And let me do that again. Right, so let's go ahead and do this again. So we'll turn on the mesh and the geometry. So right now the geometry is on, and then if we click this button here in the top toolbar, and we zoom out a little, you see the geometry is no longer there. Let me turn on the geometry again. Let me zoom in, and you can see the mesh lines are not visible. That's because the geometry is being displayed. And notice here on the cylinder, there's actually two lines. One line is for the geometry, and the other lines are for the mesh. So if I turn on the geometry and then zoom out a little, you can see now we only have one line because it's only the mesh. And then if I click this other button, it hides the mesh. So let's go ahead and display only the mesh. And now let me display the geometry for a quick moment because I need to identify where that edge is. So if we look at this edge, let's go ahead and turn on the node labels. And for this, you'll want to go ahead and click on the wireframe option, which would be this button here in the top left. And now if you zoom in, some of the node numbers are legible. This is node 191, I believe, node 127, node 163. But if you look at where the crack is, there are actually overlapping nodes. This is evidence that you have a crack or your mesh is actually separate. And think back to the geometry in Apex. Here, the crack is noticeable. There is some non-zero distance in the crack. But here in Patran, when you build your geometry, from far away, it doesn't look like it has a crack. But if you look at the node numbers, and if you know where to look, you'll actually see that there are overlapping nodes. Here, look closely, none of the node numbers are legible. Here, you're not sure if it's node 298 or some other number. If you move this a little more, you'll see the same. None of the node numbers are legible. This is evidence that you have overlapping nodes. So what happens when you go to the equivalence option and you click apply, this will search the mesh for any duplicate or overlapping nodes, and it will merge those nodes into just one node. So you're effectively closing the crack, if you will. So here I've gone ahead and done that. When you do equivalence, you get these purple circles or markers. This is indication of every node that's been merged. So if we go ahead and do the following, I believe if I just go to analysis, entire model, and let me run this Nastran analysis real quick. You'll see that when we look at our normal mode shapes, there are no longer any cracks in the model. So let's go ahead and import the results. Let's go ahead and look at maybe the first natural frequency. And we'll click animate. Perfect. So you see that we no longer have the crack in the model. So to quickly summarize what we did have a crack, something like this, except the crack was very, very small, almost a zero distance crack. And then we used the equivalence option to merge those duplicate nodes. Now, if you're watching this, you're probably someone new to Patran and MSC Nastran. I'll teach you a tip that'll help you get through the workflows faster. Now, some of you might be tempted to use Patran to create your geometry So here is the cylinder geometry. Some of you might be tempted to edit the geometry. Some of you might be tempted to use Patran to create some very sophisticated meshes. Now, my recommendation is if you have access to MSC Apex, which is closely developed to be compatible with Patran, I recommend using Apex to create your geometry and to edit your geometry and to create your mesh. You'll find this tool is a lot easier to edit your geometry and to mesh your geometry. After you have your mesh, then you can take it to a tool like Patran and finish configuring your finite element model. You can add your materials, your boundary conditions, and so on and so on. Apex also has some of those capabilities, but it really depends on what your requirements are. Some of you might be asked to do part of the work in Patran. Some of you might be asked to do part of the work in Apex. The good thing is you can use Apex for part of the workflow, you create your mesh here, export it, and then continue on in a tool like Patran. So here, maybe I'll demonstrate how to do that. I think a moment ago, you saw how quick it was to create the geometry. So what I'm going to do now is I'm going to close this gap. So here it's this edge. I want to close it up. So let's go ahead and move that edge there, and you see the crack is no longer there. And then we're going to go ahead and go to the meshing tool, click on the surface mesher. Let's go ahead and see what kind of mesh size I should be using for this. Okay, maybe I will use 0.1 meters. Okay, that looks somewhat good. Let's go ahead and throw on a fixed boundary condition. So for this, let's go ahead and turn off all the degrees of freedom for the edge. And then I'll go ahead and select this edge of the geometry. And then we'll go ahead and close that. And then we'll go ahead and add a material and a thickness to this mesh. So let's go ahead and we'll just use the dummy material. The mechanical properties don't really matter yet. Let's go ahead and assign the material. And then here we'll go ahead and click on this button, sections. This is going to let me go ahead and specify a thickness. Again, these are all dummy values at this point because we only want the mesh. We want to make sure the mesh is okay for now. So this is a preliminary mesh with some dummy materials and boundary conditions. I'm going to place this in the analysis scene, which is here at the bottom bar. And then I'm going to switch this to normal modes analysis. Now, if you're relatively new to finite element analysis, I always encourage everyone to perform a normal modes analysis. This is a good way of inspecting your mesh for any issues. If there's a crack, if there's an unconnected mesh, you'll be able to spot it with a normal modes analysis. So here I'm going into the normal modes option. So this is where we are going to be looking at the plots for the mode shapes. So let's go ahead and look at that. So here if I click on play, this is going to be the first mode shape. And then if I jump to the next mode, it should be this mode. This is what that mode looks like, and then I can flip through the other modes like you see here on the screen. So this one's a torsional load, and so on and so on. So the mesh looks good. So this is good for me. I built the mesh really quickly in MSC Apex, but now I've been asked to configure this in Patran. So what happens now? Here, click on this button here, and then click on this button, Export BDF. This is where you can output this mesh. So let's go ahead and call this mesh A. And then we'll select the units that we want to use. We'll click export here. And then if we look in my downloads directory, I have a new mesh that is ready to be used in a tool like Patran. So maybe I'll go ahead and finish that up actually. So what I'm going to do is create a new Patran database. Let's go ahead and start Patran. And then I'm going to show you how to import that mesh, and we'll do a quick analysis on it. So let's go ahead and right click and select MSC National Input. We'll navigate to that directory, select that bulk data file, and it's going to import that mesh. And then say you want to inspect for any cracks in this mesh. What you can do is go to display and then finite elements, and then click on the edges option and click apply. And then here on the top bar under the display group of buttons, click on wireframe. And then any free edge is going to have a line. So you can see that the free ends of the cylinder are, or rather they have a black line. This is indication those are free edges. If you want, they're cracks, if you will. I call them free edges. The cracks that we saw at the beginning of the video, those are free edges. But here you see that we don't have a free edge in the middle of the cylinder, so that's good. There's no crack in the actual mesh. So let's go ahead and go back and select the faces option here on the right and click apply. And so this is the mesh. Now here on the top, click on model tree. Here on the left, right click and select this load case. Now, why are we selecting this load case? By default, it's going to be loading the default load case, and the default load case is blank. But all the boundary conditions that we've defined have been imported to the untitled subcase. So if we look at that subcase, you'll notice that we have one displacement boundary condition here. So that's why we select, you know what, load and select this load case, make it the current load case. And now what it can do is the following. Here in the top left-hand corner, we'll click on force. We'll give it a name of force A. Actually, I'm a big fan of using lowercase underscore, then so on and so on. So let's go ahead and throw a load on this. Maybe we'll pull on it by, I don't know, 1 unit of force. And then we'll go ahead and select the fem option so we can select some nodes. And then here you can either drag and select, or you can use this polygon selection tool, which will let you select arbitrary shapes for selection. So here I've done that. Click add, click OK, and apply. So if you go to home and click on the background color, this will help you contrast and differentiate the different colors. So if you notice a moment ago with the white background, I couldn't read the values of the forest, but then if I turn or change the background color to a darker color, I can tell what's going on here. And our displacements, let's go ahead and turn that on with the checkbox here on the left. So here's my cylinder, I'm just pulling on it. Let's go to the analysis tab, click entire model. For solution type, we'll go ahead and select linear static. And then for subcases, we'll go ahead and modify the untitled subcase 1. Remember, this is the subcase we've right-clicked and selected. This has the fixed boundary condition and the force. If you don't believe me, you can do this. Here on the left-hand side, right-click on that load case, click show, and you'll see that we now have a displacement and force. So go back to analysis, entire model. Solution type should be linear. And then for the subcases, we'll say, you know what? Maybe for the displacements, and I don't know if this will work in this video. I'm running an older version of the application. I believe there was a conflict here, so we'll see if I can make it work. Right now, I'm going to get all the displacements data in the results file, the F06 file, which is going to be a lot of data. Maybe you don't want all that data to be printed. So there's this option here, suppress print for result type. Click OK there, or mark the checkbox rather, and click OK. Here, click apply. Now, here, let me jump into this other subcase. You notice that here in the other subcase, the checkbox is not marked. But if I go back to the untitled subcase and go to the displacement option, you'll see that it is marked. The checkbox is marked here, so that looks good. Under subcase select, now we select which subcases we want to run. We don't want to run the so-called default subcase. It's empty. We want to run the untitled subcase 1. So let's go ahead and select that subcase, and now it's in this box. So click OK there. and click apply. And now if we look at the bulk data file that was created, you'll see that the displacement case control command has plot. That means write out the results to the H5 file or the OP2 or the XDB file, but do not write out the results to the F06 file. So why do we want to do this? For those who eventually have very large files, your F06 file could be very large. It might be 10 gigabytes. And that's because you're writing out all the data for stresses and displacements and so on and so on. If you use the plot option, like displacement plot equals all, this says write out to the HDF5 OP2 or XDB. Do not write to the F06 file. So if we look at the F06 file and we look through all of this, you'll find the following. Number one, there are no displacements here. It's all contained in the results file H5, so that would be this file here. But if we look here, we get some forces, and then we get some stresses here also. So we did get stresses because there is no plot command in the stresses command. Now, let's go ahead and look at the results. So we'll go ahead and import the results, and we'll look at a quick deformation plot maybe, just to make sure that the mesh looks okay. So the mesh does look okay. The results look a little bit more reasonable. So I know that was a lot to cover, but I realized that if you have the question about the equivalence option, you most likely have a lot of questions because you're relatively new to the software application. So to quickly summarize this entire video, if you have cracks in the mesh, make sure to use the equivalence option to merge those duplicate nodes. And also, if you want to create geometry, if you want to edit geometry and mesh it, I highly recommend using a separate tool for that, like MSC Apex. Here you saw how quickly it was to build the geometry, edit the geometry, and build my mesh. I did a test analysis in Apex. I then wrote out the bulk data file, and I moved the bulk data file of the mesh to Patran, where I finished my work. And then I ran the final analysis in Patran. So that would be this final bulk data file. So that's the answer to the question, and I think that's pretty much it for this video. Thank you.